Class example 4.33. Given the function g of x is equal to 2x plus 6 over 3x minus 3, determine the domain, range, equation of any asymptotes, and the coordinates of any intercepts, and then sketch labeling all identified characteristics. So first thing we'll do is factor out the coefficients to see some of the characteristics. Now we can see that the factor in the numerator is showing us where our x-intercept is. So in this case, it's going to be at x is equal to -3, because if I threw -3 in for x, that would make this equal to 0, which would make the whole thing equal to 0. If we look at the denominator, we're going to have a vertical asymptote at -1, which is the value that would make this factor equal to 0, which would have us dividing by 0, which can't happen. The horizontal asymptote is going to be at the ratio of the leading coefficients, and we're only going to be able to get away with this because the degree of the numerator is the same as the degree of the denominator, and you can see that from either version of the function. So in this case, it's going to be 2 over 3. Notice that it was also 2 over 3 before we factored it. So for the horizontal asymptote, we didn't have to factor that to see that. For the y-intercept, we are going to set x equal to 0 and then solve for y. So we get y is equal to -2. And then from here, we can sketch it. We know that it's going to pass through these 2 points. So we know that we're going to be in quadrant 3 and in quadrant 1. And then we can sketch our relative shape. The domain is going to be x cannot be equal to 1. That's our vertical asymptote. The range is going to be y cannot equal 2 over 3, which was our horizontal asymptote. Remember, we found that from our coefficients. Again, we've already found these two values. We have a vertical asymptote at 1 and a horizontal asymptote at 2 over 3. And our x-intercept was at -3, 0. Y-intercept was at 0, -2.